Hello guys, I hope you are doing well. Here we have a video on differentiation, specifically implicit differentiation. Okay, let's get to this exam question. So we've got a curve which has equation x squared plus 2xy minus 3y squared plus 16 is equal to 0. And we want to find the coordinates of the points on the curve where dy dx is equal to 0. So first things first, we need to actually differentiate both sides of this equation. So if I differentiate, I end up getting 2x. The 2xy can be differentiated using product rule. So if I let u equal 2x and I let v equal y, I have du dx is equal to 2. I have dv dx is equal to dy dx, that implicit differentiation right there. And then the product rule is u dv dx plus v du dx. So I have u times dv dx, so that's 2x times dy dx, plus v du dx, so that's 2y. So the 2xy differentiates to this, 2x dy dx plus 2y. The minus 3y squared, well, I get minus 6y multiplied by the differential of the y, which is dy dx. So that's just the chain rule. And then the 16 differentiates to 0. So then that equals 0 differentiated, which is 0. Okay. So now I need to rearrange this to make dy dx the subject. So I'm going to take everything with a dy dx and put it on the left-hand side, or keep it on the left-hand side, and everything without dy dx and put it on the right-hand side. So I have 2x dy dx. Let me just do this because that can get confusing. It's all blue. In fact, let me even change color. Why am I doing all that? So I've got 2x dy dx minus 6y dy dx. The color change was a bit meh, but it's okay. That equals minus 2y minus 2x. Then if I factorize out dy dx, I get dy dx, open bracket, 2x minus 6y, and that is equal to minus 2y minus 2x. Then I get that dy dx is equal to minus 2y minus 2x all over 2x minus 6y. Okay, and I specifically want dy dx to be equal to 0. So I say that minus 2y minus 2x over 2x minus 6y is equal to 0, which implies that multiplying both sides by 2x minus 6y, I get minus 2y minus 2x equals 0. Whew, where do I go from here? Well, here we can see I've got a problem. I've got the x and y are in the equation, but there's only one equation, or is there? Now we're going to use the original equation as well to help us. Before I do that, let's just simplify this a little bit. So I can divide both sides by 2, so I get minus y minus x is equal to 0, or I have the x is equal to minus y. Okay, now I'm going to substitute x equals minus y into the original equation. Let's change colors one more time. Okay, let me just write this before I move down. So I have x squared plus 2xy minus 3y squared plus 16 is equal to 0. Let's move down. Now, rather than writing, so I'm going to sub x equals minus y. Okay, so I'm going to write minus y squared do I really want this or do I want a different color? I'm fussy. I'm being really fussy. Let's go for pink. Plus 2 lots of minus y times y. Didn't really need the bracket and the y, but there we go. Minus 3y squared plus 16 equals 0. So minus y squared is y squared. And then I have minus 2y squared. And then minus 3y squared. And then plus 16 is equal to 0. Okay, if I simplify that, I get minus 4y squared plus 16 is equal to 0. Dividing through by 4, or minus 4 rather, I get y squared minus 4 is equal to 0. So that tells me that y minus 2 times y plus 2, difference of 2 squares, equals 0. So therefore y equals 2 or y equals minus 2. And if x was equal to minus y, that would mean that x in this case is equal to minus 2. And over here, x is equal to 2. Which means, we're not done. The coordinates themselves are minus 2, 2. And 2 minus 2. And there we go. There we have it. That's the question done.